The next problem, number 3, is an inequality problem. The whole goal of the inequality is to get the letter on a side by itself. So this inequality sign marks the two different sides. Over here is a side, and over here is a side. Right now, we don't have the letter on a side by itself because we have plus 186 with it. So the question I'm going to constantly ask is, first question, is x, or is the unknown, is the letter on a side by itself? The answer should be no. And then the next question I'm going to ask is the letter and the number squished together? So for instance, does it say T 186? Does it say 186 T or something like that? If it's not squished together, which means it's together through multiplication, then we have to look at how it is together. So in this case, it's together through addition. And the question we have to ask ourselves is, how do we undo addition? And the way that we undo addition is through subtraction. So what I have to do to get T alone by itself on this side is take away 186. If I take away 186 on this side, I have to take away 186 on this side. When I subtract it, I can't take away 6 from 5, so I have to borrow. 15 minus 6 is 9. Can't take away 8 from 3. 13 minus 8 is 5. And 6 minus 1 is 5. So I'm looking at my answer choices. If I know that the inequality sign is staying the same, and now T is by itself because I took away that 186, I know T has to be greater than or equal to 559, which is answer choice C. So now we're going to look at number 4, and I would suggest going back to number 3 and looking and seeing the difference between the two inequalities. So in this one, the number and letter are smushed directly together. So what that means is they're together through multiplication. And if they're together through multiplication, I have to ask myself, how can I undo multiplication? And that's going to be with division. So I'm going to divide this side by 5, and what I do to this side, I have to do to this side. So 5x divided by 5 will just leave me with x, and 20 divided by 5 will leave me with 4. So what I'm left with is x is less than 4. So now I have to look at the answer choices. Immediately I can cross off F and J, because when I'm using this less than sign or the greater than sign, I know that I have to use an open circle when plotting it on a number line. When I use the less than or equal sign or the greater than or equal to sign, then I have to use a closed circle when I'm plotting it on a number line. In this case, since I just used this one, the greater than or less than sign, I know I have to use an open circle. And that for that reason, I can cross off F, and I can also cross off J. Now what else I know is that x has to be less than 4. So if I ask myself, can x be 3? Well, if x is less than 4, then yes, it can be 3. Can x be 2? Yes. So all the numbers less than 4 would be the answer. But we have to have an open circle because we cannot include 4, because 4 is not less than 4. 4 is equal to 4. So G would be the right answer. H is wrong because it is all the numbers that are greater than 4. So in the next problem, we also have inequalities. This one looks a little bit different though. Number 5, which equation has a solution of z is greater than 1.3? So here's what we need to do. We need to plug in 1.3 for z in each of these. So what it would look like would be this. 3 parentheses 1.3 is greater than 3.9. And we have to figure out if that's true. So once again, if the numbers are smushed together, that means they're together through multiplication. So I'm going to multiply them out. 1.3 I'm going to write like this, and 3 I'm going to write like this. So I have 39, and then I know that I have one number behind the decimal. So 3 times 1.3 will give me 3.9 is greater than 3.9. And a lot of people would circle this answer. On last year's STAR, there was a question very similar to this, and this exact answer where the number was greater than the number was the one selected. But you have to know that 3.9 is not greater than 3.9. 3.9 is actually equal to 3.9, but we're looking for the one that makes z greater. So this is not the right answer. So now we're going to go on to B. And once again, we're going to place z with 1.3 plus 8 is greater than 10. So 1.3 plus 8 will end up giving us 9.3 is greater than 10, which is not true. So B is also incorrect. On answer choice D, once again, I'm going to replace z with 1.3. I know that when the numbers are smushed together, that is a multiplying. So I'm going to multiply 2 times 1.3 and get 2.6 is greater than 2.7, which I know to be incorrect. Lastly, I have 2.6z is greater than 3.3. So I'm going to multiply this one out again. I'm going to break down 2.6 like 20 and 6, and I'm going to break down 1.3 as in 10 and 3. So now I have 200, 60, 60, 18, and when I add it up, I should get 338, which with a decimal is 3 3/38, is greater than 3.3. So when I line these numbers up, 3.3, I can't tell which one is bigger by the first place value. I can't tell which one is bigger by the second place value, but I know a blank spot is like a 0, and this 8 is definitely bigger than the 0, so I do know that this number is bigger, which would make this true. So if we plugged in 1.3 for z, our inequality would be true. So that is the one we're looking for.